So whenever we're doing this type of elasticity, we're going to be using what's called the midpoint method for calculating elasticity. And the reason why we do this is because it is not always clear from which point to which point we are going, right? So when we did percentage changes growing up in middle school and high school and stuff like that, right? And even just, in everyday life, for the most part, right, we were doing new minus old over old times 100, right? This was our typical percentage change formula that we learned. This is no longer going to serve us well in economics. Instead, we are going to be looking at, so let's go ahead and do an example of percentage change in the quantity. We are going to look at Q2 minus Q1. So we start out the same, right? New minus old. You can think of 2 as new, 1 is old. Divided by, and then here's where it's different. Instead of just divided by Q1, we're going to divide by the midpoint. So we're going to do Q1 plus Q2, and then divide by 2. Any questions on that, on using the midpoint method? Cool. So, not proportionally, I shouldn't overuse that word, but correspondingly, a percentage change in the price is going to be P2 minus P1 over, you guessed it, P1 plus P2 over 2. And so with most things, the best thing to do is an example, right? All right, so give me a product that is somewhere between the price of $60 and $100, or service. House cleaning? House cleaning. So, when we're talking about the market for house cleaning, we have our price on the y-axis. We're going to start off with a little break and start off with 40 down here instead of 0. And then we'll do 60, 80, 100, 120. And we're going to do a break here and start out with 1,500 and 2,000 and 2,500 and 3,000. All right, so we are given some points along this line. And we are going to do some elasticity measurements. So the first one we're going to do is we're going to do some elasticity measurements at the very top of the line. At the very top of the line. So the first point that we have is a price of 130. And so since my price is on the y-axis, I'm going to say that second, right? Just to keep with that XY convention. And the quantity demanded is going to be 1,600. So at $130 a house, there's 1,600 house cleanings demanded in Chadron every month. If that price were to decrease from 130, or sorry, let's fix this. Let's do 180 and 120. If that were to decrease to $100, at $100, we would be somewhere right here. So we would be around $22 100 houses being cleaned. I tried to do this to make the midpoints easy for me. So now I'm going to ask you all, and this would be good practice to try to do on your own, what is the elasticity of demand between these 2 points? So I'll give you kind of half a minute to start, and then I'll start, but I won't say anything. So for those of you that want to quiz yourself, you can just kind of put your head down and see if you get the right answer. This is not the easiest example in terms of numbers, but at least it's got a lot of repeating stuff, which is kind of cool. And this ends up being 11.11 repeating. Oh wait, sorry, not that, it's 1.1 repeating. I have a typo here. It's 0.2, not 2. 0.2 divided by, yeah. Burp. I'm like, that's way too elastic. All right, so how did we get to this number, right? So this is telling me that it is slightly greater than 1. This is elastic, but it's not overly elastic, right? It's probably closer to my unit elastic than it is to actually being elastic. But technically, I would say if it's outside of 0.05, if it's outside of a what is that, a fifth hundredth, a fifth hundredth? I don't know. Outside of 0.05, then you can just say that it's elastic, right? So this is close, but elastic. So how did we get to it? Well, first we found the percentage change in the quantity demanded. So I labeled them Q1 and Q2. I took Q2 minus Q1, and then I just knew that the midpoint between the two was, oh, it's not shit. I guess my shortcut was not good, right? I made a mistake here. This should, nope, I did not. I'm making mistakes in overthinking myself. Okay, great. I was fine. So I just knew that the midpoint between 2,000 and 1,800 was 2,000, right? They're both 200 away. So just on the number line, I could just clearly see that. Same thing between 110 and 120. I know that the midpoint between those, or sorry, between 100 and 120, I know that the midpoint between those is 110, right? So I kind of saved myself a step there. But if I needed to get these numbers, right, I could always just go 100 plus 120 divided by 2, which is 220 divided by 2, which is 110, which is what I ended up getting, right? And you can do the similar kind of thing in order to get the 2,000 in the denominator for the percentage change in the quantity demanded. So when we get the 2,000 in the denominator for the percentage change in the quantity demanded, 400 is 1/5 of 2,000, so the whole thing ends up being 1/5 or 0.2. I did make a mistake over here. I went ahead and I did not include this negative sign, right? 100 minus 120 is in fact negative 20. So this should be negative 0.18. And then we would end up with a negative here, and then at the very end we would do a absolute value of that and say that it is then greater than 1 and elastic. So that is one point where I shouldn't have applied the absolute value so early, right? We should wait until the very end for that. And when you're doing an elasticity of demand, one of them should be negative, right? If both of them are positive, then that that is indicative that, you know, you made some sort of mistake along the way, right? You somehow, you know, switched and, you know, you did Q2 and P1 instead of Q2 and P2. Does that make sense, everyone? How to use the midpoint formula and calculate those elasticities? All right, now one of the important things that we're going to learn real quick is that the elasticity along a flat line like this does not stay the same. So very quickly, we're going to go ahead and we can use, let's use some different points here. Let's go down here. And we are going to now use 60 and 70. So let's go actually down here. So we're going to do 60 and 3,000. And then we are going to do 2,870. So once again, if you want, you can go ahead and you can label these, kind of color code them. That definitely helps some people. And so our percentage change in the quantity demanded down here is going to be 3,000 minus 2,800 over 2,900. That's the midpoint between the two. So that ends up equaling 200 over 2,900, which is some gross fraction, right? 2 over 29. That's going to be 0.069. And then in order to get a percent, I've also been forgetting to do that, right? In order to get a percent for this stuff, what do I have to do at the very end of it? I have to multiply it by 100. So this 0.069 ends up being 6.9%, right? That is my percent change in my quantity demanded. So let's not forget that they are percents at the end of the day. Now, if you forget to do that in the numerator and you forget to do that in the denominator, well, they're going to cancel each other out anyways, so it's not a big deal. But again, just for completeness, these are percentages, right? All right, and then our price change is equal to, do we have a question? Is everything clear? Do we need to back up a little bit? Are we complaining because it's so easy? Because that'd be awesome. So again, I got to not make that mistake. 60 minus 70 is negative 10, right? Negative 10. And this is a downward sloping demand curve, so we are going to expect the elasticity to be negative, right? Because any kind of price change is going to have the opposite quantity change. So since this is a positive price or quantity change here, we're going to assume a negative price change. And also we can just see there's a negative price change. We're going from $70 to $60, right? So this negative 10 divided by 65 times 100 ends up giving me negative 15.4 as my percentage change in my price. So then when I put them all together, . what do I end up with? I end up with a negative 0.45. I take the absolute value of that, and I get just 0.45. So this demand, the demand over this portion of the curve, right, is less than 1. That's what we just found. The price elasticity of demand of this region above the curve is greater than 1. So what we find is we find that the elasticity of demand changes along this curve. So on a straight demand curve, the elasticity of demand on one part could be elastic, and in another part can be inelastic. And so some demand curves look like this. And essentially, this is you can think about it as this is the relevant range of this demand curve, right? But if we wanted to think about the demand curve in its entirety, the demand curve is really, really long, and this is that last portion of it, that inelastic portion. Maybe that's all that we have on our graph here, is that inelastic portion when the slope is so steep like that. But it's important to remember that when it's a straight line, the slope is changing along that line somewhere. So we can say, yes, this is a inelastic, we can just say, yes, this is an inelastic demand curve. But I think as conceptually understanding the fact that, there's a range of demand that might not be relevant, it's too high in price or whatever the case may be, but there is still this theoretical range of demand where, the price is more elastic than it is in this very inelastic range that is being shown in the current example. So questions on elasticity, calculating it. If this is inelastic, then what would elastic be? Elastic would be something very flat. Something very flat like that, right? Where, if I change my price by, 10 cents, that's my change in my price. There's going to be a significantly larger change in my quantity demanded. And instead of 0.10, I should probably say if there's a 10% change, right? There's a 10% change here, and we're in a elastic range, then that means I'm going to have a 10, 20, 30, 40, 50% change in my quantity demanded. And so this is an elastic curve. And again, there is a part of this elastic curve way, way, way down here, right? And it might be, and again, this is why it's kind of theoretical, right? It might be a part of the curve that's, below 0, but there's still some part of the curve that is inelastic, right? So in the same way that there's some part of this curve way up here that's, out of focus, that's, more elastic. In the same way of this elastic curve, there's some part, theoretically, if you continue it where it's inelastic. All right, let's move on to price elasticity of supply. We've got a few more things to cover. So most of our questions are going to be dealing with price elasticity of demand.